Good evening, everyone. Welcome again to the second uh, discussion that we are doing in Anova. Uh, I have streamed this live previous week, wherein we were discussing the t-test and Anova. Though I have attempted to take t-test and Anova both on that day, but since we could not complete it because we have certain questions. So I thought that I should complete this discussion, and this is the reason that I think I have taken up Nova once again. And so I think we can start. So first thing first, let me again tell you at the onset that t-test and ANOVA, they both are the difference of mean tests. When a t-test was helping us in understanding that whether the difference between the means of two groups is significant enough or not, the ANOVA tells us the same thing, but the only difference is that it takes more than two groups. So this is what the ANOVA does to us. I think we should start by understanding the basics of the ANOVA also. And before that, let me remind you what we have already discussed last time, that when we talk of any test, the very basic important thing is the variation. The variation in data is something which is making us to do whatever we are doing. So if there is no variation in data, we would not be doing research. So variation is the thing. That is something that is very much important for us to understand. So in that spirit, t-test and ANOVA both, they are testing whether the variation across the groups as far as their means is concerned is significant enough or not. So this is what both the tests are actually doing. So now, when we are transitioning the discussion from t-test to ANOVA, I think let us look at the difference between these things. So we have already done t-test. So t-test is checking the difference between means of two groups. Right? So this is what t-test is doing. Uh, the ANOVA is also doing the same thing, but the ANOVA is checking the same thing. I can copy this line and I can kind of paste this line, but it would come more than two groups. This is the difference between the t-test and ANOVA. Uh, so which means if I can take group 1, which is say male, and I can take group 2, which is say female. So suppose the mean on any statement for group number 1, which is male, is 1.23, and for female it is 1.30, suppose. So when we were checking whether this 1.23 is significantly different from 1.30, we were doing t-test. So t-test is for two groups. When we are increasing this, when we are increasing the number of groups, many times we come across the situations. Our study demands us to check the means and uh, to scrutinize the means for more than two groups. And when we are doing that, then we require ANOVA. So ANOVA is a very powerful statistical technique, but it is a very basic technique at the same time. So in that spirit, let us try to understand. So for that, we would take up a hypothetical case just to make you understand that what does it actually do. So to take up this hypothetical case, what I'm doing is I am actually making up this case. Suppose we have this column as group and in this group we have certain categories, and these categories can be Suppose we take the categories of these two groups as occupation. Suppose someone is not working and someone is working. Let's take it as a businessman, and someone is a student, and someone is a farmer. So these are the occupations of the people, and here we have four groups. And suppose we are trying to test the people who belong to these four categories, uh, and we are trying to understand that are the means of the people who belong to these categories are different from each other or not. So suppose it can be like that, he loves shopping, suppose, and this is the question. And on that question, suppose we've got and we've collected the data, and in that data we might be getting a mean of 1.2, 2.1, 3.1, 2.4, whatever. So if we are taking a Likert scale, if we are taking a Likert scale, and in that we have 1, 2, 3, 4, and 5 things, so one can be strongly disagree, and this can be disagree, and this can be neutral, and this can be agree, and this can be strongly agree. So suppose this is the Likert scale on which we have recorded the responses, and suppose these are the means that we have got. So the people who are not working, their mean is 1.2. So 1.2 comes somewhere around strongly disagree. So the people who are not working, they don't like shopping. They don't love doing shopping. So this is what we are coming up at. Businessmen, they also don't like shopping because they are disagreeing. They are saying 2, so 2 is disagree. Student, they say 3.1, so 3.1 is still agree. Farmers also don't like shopping, so they are somewhere around 2.4. So majorly no one is coming around agree and strongly agree. So uh, everyone is kind of disagreeing, or we can say, at least in this data, in this hypothetical case, we can say that no one loves shopping. So this is the overall thing which is coming up, that no one is loving shopping. But uh, this is not the it. We also need to see, can we still make some distinction here? Can we still make some distinction? People don't like shopping, they don't love shopping, but still can we say that the businessman or the student who are scoring higher mean than businessman or those who are not working, can we say that the businessman people are different from student as far as their liking towards shopping is concerned? This is something that we might need to check, depending upon our you know depending upon our objectives, right? So this is something what this can do to us, what Anova can do to us. So in such cases that we are doing here, we would do Anova, right? So Anova is analysis of variance, right? So analysis of variance, so let me correct the spelling, ACE. So this is analysis of variance. Now so Anova, like any test, it has also some assumptions, and these assumptions, let us talk of those assumptions in Anova. So I am coming up, I am bringing this thing here so that you can see it doesn't create problem to you. Let me bring it here. So this is Anova, analysis of variance, and let us talk of its assumptions. So number one assumption for Anova is uh, that the groups or the variance across the groups being studied should be homogeneous. So which means the people who are not working, there is this group. Now suppose these are number of cases. So suppose not working people were 56 in our data, suppose businessmen were 100, suppose the students were 200, and suppose the farmer were 89. So now these 56 people who are not working, they would have replied, someone would have replied 1, someone would have replied 2, someone would have replied 1, someone would have replied 2, someone would have replied 3, someone would have replied 2. So 56 people have replied onto this question, that I love shopping. And then they've got the mean, which is 1.2. So since you have 56 people responding to this question, we can talk of the variance within the responses of this 56 not working personnel here. So, so which means this group number 1 has some variance. It has some variance. It has some variance. It so spelling getting wrong. It has some variance. Now, same is with businessmen. So this group would also have some variance. Equally, the farmer group would also have some variance, right? So now this variance thing is something that we are interested in when we say and talk of this assumption, right? V A R I A N C E. Okay. So which means whatever is the variance of this group, this should not be too much different from the variance of this group, and should not be too much difference from the variance of this group from this group. And this is an important assumption, right? And this is the number, this is first assumption, and it is this assumption, right? So variance across the groups being studied should be homogeneous. This is what actually we are looking at as the number one assumption of Anova. Very important assumption. And it is primarily because if you would go to the books of statistics, you will find that analysis of variance is using F statistic. And F statistic, if you would see, it is basically a ratio of variance. So it is a ratio of variance. So ratio variance, which means numerator it has variance, denominator it has variance, and when it has numerator and denominator in variance, so if the variance is not homogeneous, it's kind of giving either inflated or a deflated result. So this is how we kind of look at it. So this is the number one assumption. Now then, how to check it? So we have a test called Levine statistic, using which we check whether this assumption is fulfilled or not, right? So we have number one assumption, which is the variance should be homogeneous, and we use Levine statistic to check it, right? So interpreting the statistic here, if the significance value is greater than 0.05 here of Levine, we say that variance across the groups is homogeneous. This is what we say, right? So this is how you interpret it, right? So if the significance value is more than 0.05 for Levine statistic, we say that variance across the group is homogeneous. So we say that this assumption, which is like variance across the groups being studied should be homogeneous, it is actually met, and so we can kind of say it is green. So this is the first level check that we do, right? So very important to do it, and this is perhaps the most important thing. Now other things, because Anova is a parametric test, so the other assumptions being that the data should be normally distributed, and when we are talking of a large sample, last time also we were discussing that for a larger sample, we assume that the data is distributed normally, right? So this is the thing that we need to check. This is a very, very important thing that we should check, that whether the data is distributed homogeneously or not before applying Anova. Now, what else to check? What else to check? What else to check while applying Anova? So first thing that we need to check here is that Anova has a dependent variable and an independent variable. So it has both the things. So uh, dependent variable, dependent variable, and it also has independent variable, right? So it has both dependent and independent variable. The dependent variable should be on metric scale and independent should be on categorical scale. Very important thing that you need to check. So if your data is not on metric and categorical scale, you might not apply Anova. So which tool to apply? If we can talk of this, we can apply Anova, right? So if this is the case, right? So if your dependent variable is on metric scale and independent variable is on categorical scale, you apply Anova to it. If your this dependent variable is on metric scale, independent is also on metric scale, you apply regression analysis, right? So you apply regression analysis. So regression also we will talk at some point of time, but now we are talking of this Anova. So I am also marking it in green, or let's make it yellow because it is a little different than what we were discussing about. So this is what else we need to check while we are applying Anova, right? So our dependent variable has to be metric scale and independent variable has to be categorical scale. Now, what will be your independent variable? What will be your dependent variable? That depends upon your research question. That depends upon why you want to apply Anova, right? Now, for example, in this case, when the question is he loves shopping, now this thing is your dependent variable. This thing is on dependent variable. And dependent variable is like measured on Likert scale. So Likert scale is a metric scale. So that is how we talk that the dependent variable has to be in metric scale. Now, independent variable is on categorical scale. So categorical scale is like this group, right? This group is categorical scale: not working, businessman, student, and farmer. Now we also should understand that metric scale are what? Metric scales. Metric scales are interval scale, and ratio scale, right? So if your data is measured on either interval or on ratio, you say that it is okay, it is on metric scale, right? Then you have the categorical scale. Categorical scale is like nominal scale is a categorical scale, right? So classification, if you have done, so here we have done the classification. Now the metric scales are also called as continuous scale, right? Continuous scale. This is also called as non-continuous scale, right? So these are some terms which you might find across some statistics books, that metric scale is also called as continuous scale, and the categorical scale is also called as uh, non-continuous scale. Now why it is called as continuous scale and why it is called as non-continuous scale, a very quick thing onto this, because see, this Likert scale is considered as a continuous scale. So why it is a continuous scale? Because the lowest value possible for this Likert scale is 1, which is strongly disagree, and the highest value possible is 5, which is strongly agree. So there is continuity in this entire scale. You see, 1 and 2 are not discrete, so the values between 1 and 2 are possible. They exist, they actually exist. So that is why you got a mean of 1.2, right? That is why you got a mean of 1.2. So likewise you have a value of 1.3 also possible. Likewise you have a value of 1.5 also possible. When this thing exists, so that say there is a scale which is continuous from 1 to 5, it is not breaking in between, that is why it is a continuous scale. Whereas for categorical scales, there is a break in between. Now, for example, if you've given in your data 1 to not working and 2 to businessman, so there is no value possible which is 1.5, who is half not working and half a businessman. So between 1 and 2 nothing exists, and that is why it is called as non-continuous scale, right? So we use nominal scale for classifications, and that is why we say that it is a non-categorical scale. So having said that, now you check whether your variance is homogeneous or not, or you check whether your dependent variable is on metric scale or not, or your independent variable is on categorical scale or not. So when we are doing this in our example case, we are understanding whether uh, the love towards shopping is different among the different occupational people. So the people who are in different occupation, are they different as far as their liking towards the shopping is concerned? This is what our case is here, right? So first thing first, we will check this, and then this we will be checking using Levine, and Levine we will be checking significance. And if the significance, this condition is met, if this homogeneity condition is met, then we go to Anova, right? Then we go to Anova. So if I can do it like this, so follow-up things are, follow-up thing is, if uh, homogeneity condition is met, go with Anova results, or go with F results, rather I should say. As I was telling you that the Anova is using F statistic, right? So you can go with F statistic if your homogeneity of condition is met. If not, then what? If suppose the significance value is coming out to be less than 0.05, in this case, I think we cannot go with F test, because F is a ratio variance test. So if the variance is not homogeneous, then we kind of cannot go with F. We cannot believe on F, because F is either giving inflated results or it is either giving a deflated results, and hence uh, it does not make sense to us to go with F test. So in that case, we will go with robust tests. Robust tests, and robust tests are two. They are Welch and Brown Forsythe, right? These are the two robust tests. Use only when homogeneity condition is not met, right? So this is when you use these things. So these are some basic things about Anova and about the application of it. So you need to take care these things in your mind. So first of all, before applying, you should have a dependent variable which is on metric scale. You should have an independent variable which is on categorical scale. You should have then you when you have these things, then you should check whether your variance across the groups is homogeneous. You check that using Levine. And how do you check it? You interpret it by looking at its significance value. In statistics, in SPSS, you get the significance value as p value. So if it is larger than 0.05, you say that yes, it is homogeneous. If it is not, then this case comes in, the homogeneity condition is not met. And when it is not met, then you go with robust tests, which are Welch and Brown Forsythe. So this is like kind of a basic thing to it. Having said that, I think we can now go to our SPSS file, so that we can kind of run it in actual, and that I think will help us in understanding it more. So with this, I think we can go to our SPSS thing, and when we can go to our SPSS thing, we can actually look at the actual application of what we are kind of discussing. So here I have opened up this SPSS file for you. This SPSS file obviously is carrying some dummy data, and this dummy data would help us in understanding and uh, applying the Anova, right? So let us try to understand what we have discussed conceptually here. So if I can show this file to you, what we are about to do. This is the data view. and this is the variable view, and I have some questions here. Now the first question is, I like this advertising very much. This is the same file that I was discussing the last time when we were discussing T, and it has the 5 options which are like strongly agree, agree, neutral, disagree, and strongly disagree. So this is a Likert scale. So I'm going to take this as my dependent variable. Now this dependent variable is on metric scale. You can see it has 5 options which are on Likert scale. So that means my first condition which I need to check while I'm applying ANOVA is my dependent variable has to be metric scale. This is on metric scale, so it makes sense to me. Now then I need a group. I need a group to apply ANOVA, and that group I think I can come down and I can look at, say, the occupation, right? And in occupation, you see this is occupation thing, and I have some groups here, and I can click onto this. I can come to know that these are the groups. So businessman, government job, private job, not working, and student. So I have 5 groups, right? So this is going to be my independent variables. When I'm running this ANOVA, what I'm checking? I'm checking whether the people who are into different professions, do they have a different liking when it comes on to advertisement which is shown to them. So I like this advertisement very much. An advertisement was shown to these people. Some of these people are businessmen, some of these people are students, some of these people are private job people, some of them are government job people. So what we are interested in is, when we are talking of a government job or of a private job, uh, are these people different in their opinion about when it is asked to them that they like this advertising or they don't like this advertising. So now let us quickly do this. So for that I'm going to analyze, and then I'm going to compare means. So you go to analyze, you go to compare means. This is the place where you have the t-test and you have ANOVA both. So here you have compare means, here you have one-way ANOVA, right? So this one-way ANOVA you will click and you will get a window. So this window will come like this. And in the left hand side of this window I have the full questions that I have in my data, and this is the question that we are taking here as dependent variable, and that is shown to you dependent list, and I am taking this in. So this has come inside, so I like this advertising. Now this is my dependent variable. Then I would go to my independent variable, which is a discrete variable, which is a non-continuous variable, and that was occupation, right? So I'm selecting occupation and I'm bringing in here into the factor, right? So this is what primarily you need to do. You need to have a metric scale dependent variable. You need to have a non-metric scale independent variable. These two things you must have, and then you can kind of look at this. So the first thing that you should do is to go to options. We will come to the rest of the options also, but we first go to options, and in that option, when you will click onto this, you will come up with this window. And this window you have certain options. So the first option is like statistics, second is mean plots. So first of all, let us have a look at the mean plot, and let us say continue, and let us say okay. So by doing this, what I'm doing is I have run ANOVA, wherein I am interested in seeing the mean of the people about a question which is on a metric scale across the professions. So now you look at this. We have businessman, we have government job, we have private job, we have not working with student. Now this curve has come because I have populated and I've checked to the mean plot into that, and that is why it has come. So you can see onto the vertical side of it you have the mean values, onto the horizontal side of it you have the categories of the people. So we know that the businessman, from this we know that they are having a mean of 2.2, right? So the government job people are having a mean of around almost 2.3. Private job people are having a mean of 2.25 maybe. Not working people have a mean of almost 2.4, and students have a mean of 2. right? So this is what we look at it. Now, looking at it from a plain eye, we might argue that the students and not working have the largest difference in their mean values, right? So the students, you see the gap between these two dots. So we know that the students are having a mean of 2 and the not working are having the mean of 2.4. So we might say that the students are different from those who are not working, who are not doing anything. They are not student, they are not working, they are sitting idle in their home. So there is difference between their means. At the same time, by our naked eye, we can also look at it like this, that the businessman people mean, which is 2.2, is not different from the government job people, which is around 2.3. So there is not much vertical distance between these two things. And likewise, government job and private job people, there is not much difference between these two. So wherein the plain eye tells us that if we consider this as a group, there is no difference in the means. But if we look at student and the not working people, there might be difference, right? So I think it makes sense for us to run ANOVA when you have things like this. So let us go to ANOVA now. So I'm now going to analyze compare means one way ANOVA, and the same thing is already populated because you have done it once. So I'm going to options, and then you click onto the descriptives. The first thing that you will click is descriptive. So the descriptive, as I was telling you the other day also, is something which will give you the basic statistics, which is like the mean, the median, the mode. These things would come to you when you standard deviation, the variance, the minimum value in the data, the maximum value in the data for this statement. So those things will come in descriptive. Then I think we need to check onto the homogeneity of variance test. This is very important. The fixed and random effects is not important to us. This is internal calculation. So we will go to homogeneity of variance test. Now, homogeneity of variance test is something when we were discussing onto the Excel. If I can take you onto the Excel, you see this is what we have discussed. We should be having variance homogeneous across the groups. How do we do it? Using Levin statistic. So we are kind of looking at this. So this is that homogeneity of variance test, right? And then I can uncheck the means plot because we have already looked at it. So this is the basic level check that I have done, and now I say continue and I say OK, right? So doing this gives me an output which is like the first thing is like I'm having the categories and their mean values, right? So 2.20 is for businessman, government job are 2.28, private job is 2.25, and this is the same thing we were looking at this in mean curve also, right? So 2.2 for businessman, and this is here 2.2 for businessman, right? So this is the same thing, and this is standard deviation, this is standard error. We have looked at what the standard error is. In the previous discussion, we were saying that if the sample would change and from the same population, so this much of difference is expected into the results of the mean of this statement for the businessman people. So this is like we are looking at the descriptives. Now this is an important thing for us. Levin statistic, Levin statistic. So Levin is testing the homogeneity of variances, which is an important assumption in ANOVA. And in SPSS, you got this Levin table, and in Excel, I have shown this to you. So if I can do this so that you can recall, we were looking at this Levin statistic. So we were saying if, let me bring it like this, and let me make it little bigger. Yeah, wonderful. So we were saying if significance is greater than 0.05, we say the variance across the group is homogeneous. And here the significance, you see this is the significance. This is 0.177, which is obviously, if you would look at it here, is obviously greater than 0.05. So we say that homogeneity of variance condition is met. So which means the businessman, government job, private job, not working, and student, these categories do not have too much of difference in their variances, and hence we say that the variances are homogeneous across these groups. When variances are homogeneous across these groups, then we can kind of how to interpret it. Follow-up things is, if homogeneity condition is met, go with F results. Go with F results. So now I will go to my SPSS file again and look at this Anova table now. Anova table is using F statistic, right? And then you will look at F. So how to interpret F is, if so interpreting F would tell you if significance of F is greater than 0.05, we say that there is no difference. There is no difference between the groups, right? This is what we say. And when we are saying this, we need to kind of make sense of this by looking at this table. So if the significance of F is greater than 0.05, we say that there is no difference between the groups. So this significance we are talking about here, 0.09, which is obviously greater than 0.05. So we say that there is no difference between the groups. So which means, though the mean of these 5 groups are different from each other, but on the basis of this difference in means, uh, these groups should not be treated as different as far as their liking of this particular advertisement is concerned. This is how we are going to interpret it. So what do we further say is that the overall mean is 2.09. So wherein the individual group mean is different, but we might say that they all are disagreeing, because 2 for us is disagree on 5-point Likert scale. So all of them are disagreeing that I like this advertisement very much. So which means none of them are liking this advertising much, right? So this is how we kind of do that. So likewise, you can also quickly do this, compare means, one way ANOVA for another factor. So I am bringing in suppose education, bringing in this factor. Everything is same. I am saying okay. And when I'm saying okay, so this is throwing me a table, and this is the table. So senior secondary 2.17, graduation 1.17, post graduation 2.19, and MPhil and PhD are 2.33, right? So the overall mean is 2.09. So first thing first, we go to Levine first. So this is test of homogeneity of variance. The Levine here is 0.754. So that means the homogeneity of variance condition is met. So which means across these groups, uh, we have the homogeneity of variance condition met. So we can go with the results of F, and we can look at the significance now. So this is 0.249, and that means that there is no difference as far as the mean of these all groups are concerned. Now, uh, having said this initial level of discussion of ANOVA and how to interpret the results, there are some very important things that we should actually be looking at. Now, looking at this table, which is currently highlighted in blue, we see that the MPhil and PhD students are only 3, right? MPhil and PhD students are only 3. So does it make sense to have only 3 people in one group, and then comparing it with a group which is 68, which is, and then 97 in graduation, secondary, senior secondary are 42? Better you kind of club it with say post graduation, because those who are MPhil and PhD, they would be post graduation obviously. So you kind of take these and such decisions so that you do not end up in having some confusion around your data. One more very, and it is in fact super important thing, this assumption that we are talking here, this assumption that the homogeneity of variance should be homogeneous, I'm writing it down. There is an exception. There is an exception to this condition. What is that? If the group sizes are equal, we might relax this assumption of ANOVA. If
if the group sizes are equal. Super important. Let me highlight it with different color. So let's make it blue. This is exception to this condition, the green condition, that variance across the groups being studied should be homogeneous. We can relax it. Exception of this condition is if the group sizes are equal, we might relax this assumption in ANOVA. So which means having looking at this current case with that exception, we have senior secondary people 42, we have graduated 797, we have postgraduates 68. Now obviously they are different. So had the case been that senior secondary people are 97, graduation people are also 97, post graduations are also 97, we might know to do this homogeneity of variance test, right? And then we can directly come to F and we can make sense of this. Now this is something which is very important to understand, and that will help us in looking at the various ways by which we can look at ANOVA, and the various ways by which we might not also look at ANOVA, right? Now, this is the case when typically you have a result which says that there is no difference. Now, suppose we get the case wherein there is difference in these groups. What do you do then? Let me quickly run an ANOVA. So compare means one way ANOVA. And suppose instead of this education, I bring in, what do I bring in? I bring in, say, monthly income. And monthly income I have got it. And then I say, okay. And here, uh, the living statistic is 0.917, so it is not serving our this 917 is telling us that yes, there is a homogeneity of variance thing here. So we should go with F, and F is saying it is 0.002 now. Let us now, this is different. So let us look at this. If F is greater than 0.05, we say there is no difference between the groups, and then you add vice versa. So you can kind of copy this, you can kind of paste this. Is if you say it is less than 0.05, we say there is difference between the groups, right? So now this is this case. Now, this is this case wherein ANOVA is 0.02. It is obviously less than 0.05. So when it is less than 0.05, how do we look at it? Now there is something which is very important happening in ANOVA, because the result says that there is difference. Now have a look at the means now. The mean, the people. So let us visualize this table. The people who are earning nothing, nil, they are having a mean of 2.03. The people who are earning till 20,000 a month, they are having a mean of 2.59. The people who are earning between 20,000 and 30,000, they are having a mean value of 2.26. And the people who are earning between 30,000 and 40,000, 1.4 and above are 2. So the overall mean is 2.09, but then this is the variation. Now if I can take you to Excel again, and if I can enlarge it, right, because this is an important thing, I'm bringing in up a new sheet. So here I have how many groups? Nil, 1, 2, 3, 4, 5. I have 5 groups, they are 5. So nil, uh, till 20,000, then till 30,000, till 40,000, and above 40,000. These are the options that I have now. Suppose to make the things little better, I am doing according to it. So this is A, this is B, this is C, and this is D, this is E. Now see, we've got a significant result here. We've got a significant result here. So this is significant result 0.02. When it is significant, do we say that all the groups are different from each other? So A is also different from B, B is also different from C, C is also different from D, D is also different from E. So for now, if I can write the means, so the mean is 2.03, 2.59, 2.26, 1.44, 2.00. These are the means, right? These are the means. Now, these are the means. So now, are they all different from each other? So we say that the A is different from B is different from C is different from D is different from E. What do we do, right? Now you can alternatively also look at this from that mean curve. So you can populate that mean curve. There also you can see the difference. So if quickly we can do this analyze, compare means, one way ANOVA, and I can go to options and you say mean plots, continue, okay, you get a mean plot on this. And when you get a mean plot on this, you can see this is how the means are varying, right? So between 30,000 40,000 are sitting up with a mean of 1 point almost 5, even less than that. And then you have till 20,000, you have a mean of larger than 2.5. So, but let's look at this 2 for nil and 2.25 for between 20,000 and 30,000. Are they also different from each other? Are the people between 20,000 and 30,000 also different from above 40,000? Their means are this. And now look at this also. Compare these two groups. Nil is 2 point something, and above 40,000 are 2. And you can see this here also. So nil is 2.03, above 40,000 are 2. The difference between these two are only of 0.03. Are these means also significantly different? Can we say that the people who are earning 40,000 rupees are significantly different than the people who are earning nothing because their mean is larger by 0.03 for these cases, right? Now this is an important case. So in such cases, we must understand one thing about ANOVA. We must understand one thing about ANOVA, and this is what I will try to explain to you now. So I am kind of increasing the size so that you can see it carefully. Now, combinations of groups. So how many combinations can we talk? AB, AC, AD, AE, because we have these many groups. So we have BC, we have BD, we have BE. So likewise we have CD, we have CE. So likewise we can kind of talk of the groups that are possible. So we can talk of these groups. So between the A and B, the difference is like if I go, A is 2.03, B is 2.59, the mean difference is 0.59. Between A and C, it is only, this is no 0.59, this is 0.56, 0.56. This is the difference. Likewise, between A and C, because the C is this, and its mean is 2.26, A is 2.03, so the difference is 0.23. So likewise, you can talk of these differences. Are we saying that all of them are different from each other? No, this is the trick in ANOVA, right? So what we say is that if any one of these combinations, if everything, even if AB, AC, if BC, if BD, and if BE, all of them are actually not different from each other, and if there is only one group which is different from each other, even then ANOVA will flash the significant results. This is something very important to understand. Even if there is difference, now look at this, we were saying 1.44 and 2.59, so this is between B and this is between D, so B and D, so this difference is how much? So it is almost 0.56 plus 0.59, so which is greater than, more than 1. Now, because this difference is more than 1, this might be significant. Maybe that these are not significant. Now, look at this A and E. So, A and E is only 0.03. Do you think that this difference is also significant? We are not sure of it. So, this might not be significant. This also might not be significant. This also might not be significant. Likewise, this. But there is only one combination which is different. So, ANOVA will give you significant results. So much important to understand. In this case, we need to look at where are the actual differences, because this is not the end of the story for ANOVA. We need to look at where are the differences now. So for that, we have something which is called as post hoc tests. Post hoc tests. So if you will go to analyze, we have compare means, we have convey ANOVA, and then you have post hoc test. You see post hoc is written here. So you will click on to the post hoc tests and you will come up with this window, right? And important to note, in this window you have so many tests. So the first category of tests relates to the equal variance is assumed. Equal variance is assumed, and you have a lot of tests here. The second category is equal variance is not assumed, and you have some 4 tests here. Now, which category to choose? So I take you back to this SPSS sheet, which is in the end. So if I can cancel it, if I can drag it here, and if I say post hoc now, this window has come up. Now look at this. So my significance level for Levine is 917.917. This is telling me that there is homogeneity of variance. And if there is homogeneity of variance, we would look at this above thing, which is equal variance is assumed. Equal variance is assumed, right? So which means now we need to select any one of these tests. Now these tests which are in the bottom considers that there is no homogeneity in variances. So if this Levine would have been 0.02, so which is less than 0.05, you would have gone with these tests, but not these. Now the question is, which one is important to you out of all these things? Now the answer to this is whatever suits you, right? So the popular tests are LSD, Chaffee, Bonfermi. I have seen these 3 tests being applied more often when people are trying to make sense of ANOVA. Uh, and in equivalence not assumed, you have Tamhane's T2 the leader, because many people apply Tamhane's T2. This is the test that I have seen, right? So in our case, let's do the LSD and let's say continue. Now what this would do is, this post hoc do, as the name says it is post hoc. So once you have run the analysis of variance, once you have run the ANOVA, then you think and you talk, where are the differences? So when you say where are the differences, then you do the post hoc test. So the post hoc tests compares each possible group which with each other. So post hoc would compare A to B, A to C, A to D, A to E, and B to C, B to D, B to E. So all the possible combinations the post hoc test would do, right? And that is why it is post hoc. Post means after you have applied ANOVA. So continue, and you say okay. And when you are saying okay, you get a result. This is the post hoc result, right? This. Now you can see in this post hoc result, this is nil. This is till 220,000. So this is A for us, and this is B, right? So A and B are combined here, and then you get a significance of this. So important thing to note here is A and B are different from each other, because the significance level here is 0.001, right? This is how we kind of look at it, right? So 0.001 is less than 0.05. So wherever you see in ANOVA or in T the significance value more than 0.05, you say it is not significant, whatever you are measuring. So here we are measuring the difference between the means. Wherever you see the significance value less than 0.05, you say it is significant. And what is significant is whatever you are measuring. So here we are measuring the difference between the means. So this value is 0.001. So that would mean that this difference is significant. And the nil people are different from those people who are earning 20,000 a month, because this result is significant. So if we come here in our Excel file, so if I can have, let us do it like this. right? So significance, significance. So for this group, we have significance. Yes, they are significant, right? Because this is 0.01. So A and B not significant. This is 0.214, right? So 0.214. So 0.214 means it is greater than 0.05. So there is no significant difference between these two groups. So no, right? So likewise, you have A and C, A and D. A and D is it's also less than 0.05. So this difference, whatever is the difference between A and D, that is also significant, right? And then A and E, it is way more than 0.05. So it is no, right? So now in this case, likewise, it compares till 20,000 to all the others. Then the third C thing with all the others. This is what I have done: C with B, C with E, everything. C with A, because we have already done A with C, so need not to do C with A because this does not make a difference. And then you have this, and then you have this. So everything is taken together, and then you look at these results, right? So now we were only having the difference between this group and this group, but yet the ANOVA gave us the significant results. So what this tells us is, it tells us a very important story. That story is that if any of the groups are different in ANOVA, overall results would be significant. Whenever you arrive at significant results in ANOVA, this is not the end of the story. You need to further check it, and you check it using post hoc tests, right? So when you do not know, it is an exploration that you are doing, right? You do not know where are these differences, and these differences lie somewhere. You need to check it, you compare all the possible groups, and then you say this is where the difference is. Now how to further interpret it? A B, yes, the difference is significant. Now go to A and B. So here I am going to A is nil, it is 2.03, B is 2.59. So what is the mean value then? The mean value, we already did the mean. So A's mean is 2.03, B's mean is 2.59. So now we will say that the people who are into B category, which is the people who are earning around 20,000 a month, they are at least neutral towards their liking towards this advertisement, in comparison to those who are not earning anything. So which means the people, as they are earning, or the people who are earning initial level salary, they are liking this advertising in comparison to those who are not earning anything, because their mean is higher, because this 2.59 is way higher than 2.03, and this significance, which is yes, it tells us that yes, the 2.03 and 2.59 are statistically significantly different, right? So this is how we kind of do that. So okay, so I'm checking the chat box. Avinash has also joined in. Avinash, good evening. Rishabh, you are also welcome. Rishabh also says good evening. So I hope it is making sense to both of you and to the other participants also. If you have any question, you can kind of type in between. I'm in constant touch with the chat box also, so I can see what else is happening there. Okay, so now this is about the post hoc tests. Now, the important thing, just a quick recap and review out of this. This analyze, compare means, one-way ANOVA into the post hoc tests. You only select the above level test when you have the equivariances there, and you select the below things when you do not have equivariances there, right? So this is how do you look at it. Now, the very important thing once again, and let me also tell you that at times we are in a situation, see, this was the case when we have actually looked at uh, the combination of the groups, and we have tried to look at each every possible combination, and then we have tried to see how these results are different. Well, at times we can also do the pre-planned combinations of groups. Pre-planned combinations of groups, right? So pre-planned combination of groups means what? I can go back to Excel, uh, and I can kind of broad it. I can make it big. I can bring it down there. So these are my groups. Now you see this. Uh, what if I can kind of beforehand if I decide that let me make a group, let me combine these two groups D and E together and compare it with B and C taken together, and I'm not considering nil into my analysis because nil people, they are not earning anything, so better not to compare them. So what I'm trying to do is I'm pre-planning the groups, right? So I am kind of doing the wrapping. So what I'm doing, I'm not taking into analysis. I'm not taking this in analysis, and these two I'm combining together, and I'm making group one, and I'm combining these two, and I'm taking and making it as group two. I might also need to do this. So what I'm doing now, the people who are earning till 30,000, I'm comparing it with the people who are earning more than 30,000, keeping these people who are not earning anything as constant. Now these are called as pre-planned groups. That also you can do. So you have pre-planned groups in possible in Anova. You have post analysis comparisons also possible in Anova. So when you are doing post analysis comparisons, it is called as post hoc. When you are doing pre analysis grouping, that is called as pre-planned, and that is possible in Anova by doing the contrasts. So I am trying to do that uh, by going back to our analysis sheet, and here I've come and I'm bringing this table yet again, and now I'm going to contrast. You see the contrast, so the contrast does this. So I'm clicking onto the contrasts, and you can have many contrasts in place. So for contrast, you need to give coefficients, and I will tell you what these things are. So you see I have 5 groups. So this is what I have taken here. I have these 5 groups. I want to combine B and C together. I want to combine D and E together, and I don't want to use A into my analysis. So I have 5 groups. So I need to assign contrast to all these 5 groups. So let us look at this. A not to be taken into analysis, B and C are to be combined, D and E are to be combined. So this becomes one group. This group is being compared against this group, right? This is what we are trying to do. So for that, let's see. So we say 0 is the first contrast. The first contrast goes to the first group was nil. I'm not taking it into analysis. So minus zero point 0.5, it goes to the second thing. Minus zero point 0.5, it goes to third group. Plus zero point 0.5, it goes to the third group. This is 0.05, so change it. And then you have 0.5 to the fifth group. So this is the contrast that I've assigned. Now always keep in mind, whenever you are applying contrasts, the coefficient total has to be 0. If the coefficient total is not 0, you are in problem. So the contrast does not level up, it does not balance. Always contrast has to be the contrast total, the coefficient total has to be 0. So what I have done here is, let us look at this, and let me bring you back to the Excel sheet. So A, I have given 0, right? I have given 0 to A. B and C, I have given minus 0.5, minus 0.5, so if the sum of it becomes minus 1, right? So the minus 1. Those are zero point 0.5 and zero point 0.5. So the group D is getting 0.5, group E is getting 0.5. So their sum is coming plus 1. Their sum is coming minus 1. So plus and minus are compared in contrast. Right? So what is plus, that will be compared against minus in contrast. This is 0, so this is not into analysis. Right? So by doing this contrast, I am comparing this group with this group, and I am doing it a priori. So that means I have pre-classified the groups. So how can we do that is I say continue, and contrasts. Okay, so 1 2 3 4 5, you say continue and you say okay, right? So when you are doing this, you see it is telling you the contrast tests, contrasting what contrast have you assigned. This will give you this thing, right? So nil has got a 0, till 20,000 has got minus 0.5, between this has got minus 0.5, this has got 0.5, this has got 0.5. So these two are clubbed, these two are clubbed. Now these two are being compared. Now important thing, as was in t-test, because now in contrast you are having two groups only. So if I can take you to the Excel sheet, now you are having two groups, group 1 and group 2. Now you don't have 5 groups. And when you are having two groups, then you are kind of doing this contrast. And as you are having two groups, so you will talk of t-test. So as we were doing it in t-test, the first thing that you will do is uh, to check the Levene statistic, right? So Levene is here. So Levene says the variances are homogeneous. It is greater than 0.05. So you come to this thing, right? And when the Levene is greater than 0.05, that means homogeneity of variance is there. So you would go to assume equivariances column, and you would look at its significance, and the significance is 0.002, and this is obviously less than 0.05. When it is less than 0.05, you say these two groups are different, right? So the two groups are those who are earning below 30,000 and those who are earning above 40,000. These two groups are different, right? So this is how you kind of look at it. And these are a priori classification of groups. And when you do that, ANOVA also allows you to do this. So rest of the things remains the same, right? So this is how you look at the contrast, and this is how you look at the post hoc test in ANOVA. One thing which is now left, which I think we must discuss, is what if you get a significance value less than 0.05 here, or in other terms, when in this case, if I can enlarge it, when in this case, okay, when in this case the Levene statistic is giving you significant results, interpreting the statistic. So if significance is less than 0.05, wow, then what? We say that variance across the groups is not homogeneous, right? Variance across the group is not homogeneous. And when it is not homogeneous, we must not go with F results. Right? We must not go with F results. Right? Important thing to know. In that case, we must go with robust tests. Robust tests are the answer in such situations. And robust tests are Welch and Brown Forsythe, right? So if the Levene statistic value is greater than 0.05, you go with F and you interpret the F. But if it is less than 0.05, we must not go with F, because the condition is not met. The condition of homogeneity of variance is not met. And when it is not met, you cannot take the results of F, because they are either inflated results or they are either deflated results. So in that case, we will go to the robust test. So where do we get the robust test? So I'm going to analyze, I'm going to compare means, I'm going to one way ANOVA, and here go to options, and you see you have Welch and Brown Forsythe here, Brown Forsythe and Welch. You just check them up, and checking them up would give you this. So I'm unchecking the mean because I don't need it. So I'm doing continue, and I'm saying okay. So saying this is giving me a result which is like also giving me, so I also need not to have contrasts here, it is confusing the things up. So I am unchecking the contrasts also from here. I am kind of removing it, remove, 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 and remove. Okay, so continue. So post hoc also I am removing because we are not interested in post hoc tests. I am just interested in letting you know that how to do this down force method. So I am saying okay. Now this will give me a clean file. So these are your descriptives. This is your leaving. Now leaving is not coming significant here. We are talking if the leaving would have come significant, which means if this value would have been less than 0.05, you would not have gone with Anova's significance. In that case, you would have gone with the significance of this table, robust test of equality of means. And this has two things, Welch and Brown-Forster. Wow. So now instead of looking at this significance, you would look at the significance of either Welch or either Brown-Forster because they are more robust tests and they are not prone to this condition of homogeneity of variance. So now instead of looking at this, you would look at this if this value would have been less than 0.05. So do not confuse it because this data is not giving us this value, so that is why it should not be kind of confusing you. I am saying that if this value is 0.02 and this is the change that I have done. So suppose it would have been like this 0.02. I have changed it. It is not the actual case. I have changed it before you only. So if this is the case, then you would go with this, right? And then you will interpret the results as we have interpreted it. So the same thing goes for Welch and Brown-Forster. If this value is less than 0.05, you say significant difference exists. If it is not less than 0.05, you say there is no difference and the groups are equal. And then rest of the things remains the same. And in this case, if the leaving is coming significant, in this case, if you have to do the post hoc tests, so you go to the post hoc test and you select Tamhane T2 instead of LSD because the equivariance assumed condition is not met now, right? So you say continue and then you say okay and things will come out, right? Now, one more thing which I think is very much important to look. Uh, so here you will see in multiple comparisons, I have selected Tamhane, so Tamhane has come and it is also giving you some significant difference in that. Now, having said that, this is how you kind of interpret the ANOVA. This is kind of a full thing that you would look at it and how to interpret the results of ANOVA, how to do the prior selections and how to do the post hoc selections and how to check Levine statistic, how to then look at F and how to look at the robust tests. The last thing which is left, which I must tell you, is that there are times when the Welch and Brown's force they are speaking opposite things. So the Welch would be saying, no, no, it is significant. The Brown force they might be saying, no, 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 it is not significant. So what I'm trying to tell you is that the Welch might comes out as to be 0.004. So and the Brown force they might comes out to be. So suppose if it is the case like this, so let it be this and let us make any one of them kind of less significant, so 0.723 suppose this is what we do, right? So 0.723 and this is what we have done, so I am crossing it up and this is coming. So now if this is the case, in this case you will go with Welch. Welch is more powerful statistic than your Brown Forster, and then you will say that there are differences across the groups. What if Brown Forster is saying something else, right? So this is about Anova, and these are the various things which you must consider in Anova. I hope I have tried to consider and to look at not many things, and this I think would give you a brief overview of what is Anova, how to interpret it, and what to keep in mind and what to not keep in mind. So this is about Anova. If you have some questions, I would be happy to take up those questions. And as I always do, you can also drop me a mail. I am leaving a mail to you.
So you can drop me any questions if you have around this. I would be happy to take up those questions. So since I do not know you are from which place, it does not it should not come in between you and I when you are asking questions. You can ask your questions freely. And that is not an issue to all of us. So I think that this is a discussion on Anova. I think it will help you, and you can kind of write me, mail me, drop me. If you have kind of liked it, you can subscribe to the channel, and you can also click onto the bell icon so that next time when I will do the streaming, I can look after that also. And then you can also write into me the topics that you would like to discuss in the coming times. So that would also help me in doing this and taking up the new things in mind. So I hope the discussion has been fruitful. I hope that you would take it up and try to do it with your own data. And if you have any questions, don't forget to write me up. So thank you. You have been a wonderful audience.